Okay, write and use direct, inverse, and joint variation models. You have seen direct variation before. You just haven't thought of it this way. Direct variation is basically that you are, maybe I should take a step back, talk about this K value. This K value is just a value that you keep on either multiplying, dividing by. It's a constant number that you're given. So the way I see it is, or say that you've seen direct variation before, come on, guy, is that direct variation is essentially what we did with slope. Okay, so that number is like a slope, a constant number that we take each value and multiply a number by. So constant multiplication is direct. I'm going to skip inverse for a second. Joint variation is constant multiplication, but now it's within two variables. So I'll take two unknowns and multiply it by k. Inverse variation is the one that deals with division. So we just got talking about rational graphs before Christmas break. That's an inverse variation. You've done these again in science a lot too. Like I know that direct variation, you talked about force equals mass times acceleration, where acceleration is 9.8 meters per second squared. That would be your k value. Okay, you talked about joint variation, where I think it's like velocity or dropped objects, where it's 1/2 mass, or potential energy 1/2 mv squared. Okay, so that's like a joint variation. You're multiplying it by two different variables. Okay, so in order to identify though whether it's joint, direct, or inverse variation, in fact, we're even taking joint out of this one. It's just all about, is it direct variation or inverse or none at all, is to make sure that you either have y or x by itself. Okay, I go with y, so I'm going to divide by x here, and y equals 4.8 over x. Okay, I'm going to go back up to here, and that's some number divided by x, so that is inverse. Okay, I'm going to multiply by 1.5, and I got y is equal to 1.5x, and that guy would be direct. Neither would look like this. Like if I had y equals 5x plus 1, that's neither, because of the plus 1. There's no addition, there's no subtraction when it comes to these variations. Okay, so how do you know from a table? Well, I think of it this way. I'm going to go through and double check. Is there a number that I could multiply 5 by to get to 15? Yeah, it's times 3. How about 8 to 24? Yeah, it's times 3. How about 1.5 times 3? Yeah, so it's direct. And the constant of variation, the number that we're constantly multiplying x by to get to 3, or to y, would be 3. Okay, so 3 times what gives you 5? I'm not quite sure. 5 times whatever gets you to 21? I'm not quite sure either. So I can actually try this. 5 divided by 3. Is that the same thing as 21 divided by 3? Okay, nope, so it's not direct. Okay, is there some number that I could divide by 3 and get to 5? So maybe possibly that k be 15? I don't know. Well, 15 divided by 3, but is 15 divided by 5 21? No, so it's neither. Okay, it's neither one of those variations. Okay, so when y varies inversely, so that's the word you need to know. That's telling you that this is your model, k over x. You're given these two numbers to come up with some sort of relationship between the two numbers to find out k. So I'm going to put in 6 for y, 1.5 for k, solve for k. It's kind of like I'm solving for a slope in a way. Okay, so half of that 3, so that k value is going to be 9. So the equation with k in it for any point of x and y would be y is equal to 9 over x. So when I want to find a new value for this variation relationship, for the number x is equal to 4, I want to find the y that goes with it. I put in 4 for x and I get 9/4. Okay, so it's very much how we wrote the equation of a line. Varies jointly, forgot the s there. So z equals kxy. So I'm going to plug in these three values, and the reason why I'm giving these two numbers is to find the value of k. So 6 for z, k, 2, 4. So 6 equals k times 8. K is equal to 6 over 8, or 3/4. So now my respective equation would be z is equal to 3/4 xy. So now if I give you another x, another y, I can find the value of z by going 3/4 times 2 times -3. So 9/2, -4.5 if you're a decimal guy or person. Okay, so the volume of gas in a container varies inversely. So there we go. So I'll go with, let's see, V for volume. So V goes inversely with the amount of pressure. The gas has a volume of 75 inches cubed at a pressure of 25 pounds per inches squared. So the constant of variation between these two gases and pressures is going to be 75 times 25, and you're going to get a calculator for this, so don't worry about that. It's 1,875. So the equation would be volume is related by 1,875 over P. Okay, so that'd be your model. So what I could do is, let's say I give you this new value of P, let's say it's 15. You can take the 15, plug it in for P, and find out the volume of the gas that goes along with it. And that is your inverse jointly in direct variations. You can combine multiple variations, so we went to a whole lot of it. But W is equal to K over KXY over Z. So what's happening here is this jointly is the double multiplication, and this inversely is the dividing by Z. Okay, so just know that you can put multiple one of these together and come up with various different equations.